I am Vijayaganth, Assistant Professor Mechanical Engineering, Amet University, Chennai. Today we are going to discuss about Introduction to Beams and Shear Force and Bending Moment on Beams. Let me start. Today we are going to see about definition of beam, types of loads are acting on the beam, types of supports, reactions, shear force, bending moment, and shear force diagram and bending moment diagram. Beam is nothing but a structural member which is a horizontal member which will take load. Here we are going to, we are seeing about the beam here. The train is on the beam. The load is, vertical load is acting on the horizontal member, and which is also a supported one. In simply, beam is nothing but a horizontal member which will take vertical loads. There are 5 types of beams, namely simply supported beam, cantilever beam, fixed beam, overhanging beam, and continuous beam. We will see one by one what all the beams are there, and we will do with the examples. Simply supported beam. Simply supported beam is nothing but which is supported at both the ends. The beam is there, horizontal member is there here, and it is supported, which is supported at both the ends. So, which is called as simply supported beam, which will take loads, vertical loads, and which is supported at both the ends. Number 2, cantilever beam. Cantilever beam is nothing but which is fixed, not supported, which is fixed at one end and free at another end. Here we are seeing an image which is, for example, which is an example of cantilever beam, which is fixed here and which is extended towards left, and at the left end here it is free. So, which is called as cantilever beam. Cantilever beam is simply which is fixed at one end and free at another end. Number 3, before that, cantilever beam, for example, wings of a stationary aircraft is there, and which is a wing which is fixed here and which is free at another end. Number 3, fixed beam. Fixed beam is nothing but which is fixed at both the ends. The horizontal member is there and which is fixed at both the ends. Number 4, overhanging beam. Overhanging beam is nothing but which is supported here at two ends, and it overhangs beyond the end, beyond one end, it may be at both the ends, which will extend at one end or at both the ends, called overhanging beam, which overhangs at one end or at both the ends. This is the example. Next, continuous beam. Continuous beam is nothing but which will have more than 2 supports. Here we are saying that there are number of supports are there which takes loads. Clear? Horizontal member is there and it has more than 2 supports. So, which is called as continuous beam. Next, we are going to see about types of loads acting on a beam. There are 2 types of loads. One is point load. Next, distributed load. Under distributed load, there are 2: uniformly distributed load and uniformly varying load. Point load is nothing but the load which acts at a particular point, called point load. Distributed load is nothing but the load is distributed throughout the length of the beam or at a particular section. There are two types of distributed load. Uniformly distributed load. Uniformly distributed load is nothing but the load is distributed evenly or uniformly throughout the beam or at a particular section. Uniformly varying load. Uniformly varying load is nothing but the load will vary at point to point. Clear? For an example, a beam is there. We know that beam is nothing but a horizontal member which is supported at both the ends. A point load is acting at a midpoint at a particular point. The point load is acting at a particular point called point load. Here the image is showing that uniformly distributed load is acting there in a bridge. The bridge is already supported and beam is nothing but a horizontal member. The load uniformly distributed throughout the beam or at a particular section. Next, uniformly varying load. The image is showing that the beam is there, horizontal member is there, and the load is varying at a point to point, which is increasing from here to here and also decreasing from here to here. This is varying load. Next, there are types of supports. There are two types of supports mainly. One is pinned support, and another one is roller support. Pinned support is nothing but which is pinned at one end, and there are some reactions. In a pinned support, there are two reactions. One is vertical reaction and another one is horizontal reaction if the load is acting vertically. And the roller support offers only vertical reaction. There will be no horizontal reaction because of the roller will roll, so there will be no reaction in the horizontal direction, but there will be a reaction in the vertical direction, which is an example of roller support. A roller is there under the beam. This is pinned support. As I already told, pinned support. For pinned support, there will be two reactions. One is vertical reaction, another one is horizontal reaction. If it is a roller support, there will be only vertical reaction. There will be no horizontal reaction. Shear force and bending moment. Shear force is nothing but the sum of the loads, sum of the vertical loads acting on a particular section or throughout the beam. Bending moment is nothing but the moment will offer a bend. The moment will offer a bend on the beam. Now we will see a simple problem on simply supported beam, and we are going to draw shear force diagram and bending moment diagram for the upcoming problems. Now problems on simply supported beam. We will start with the point load and uniformly distributed load and uniformly varying load. As we see already, simply supported beam is nothing but a horizontal member which is supported at both ends. If the supports are there in ends, which is called simply supported beam. A support, pinned support, roller support, we will see, and the beam is under a point load 2000 kg. For an example, the length of the beam is 3 meters. Okay, we will find the reactions at supports, and we will draw shear force diagram, bending moment diagram. SFD is nothing but shear force diagram, BMD is nothing but bending moment diagram. First we calculate reactions at the supports. I am naming that at the left end, at the left support namely A, for right support namely B. We are finding reactions at A and reaction at B. which is simple here. The 2000 kg load, point load, is acting at the midpoint. As we already know that the support will take loads. Support will take loads. There are two supports at the both the ends, and which is symmetric one. So the 2000 kg will be shared to the A and B equally. We will calculate. Reaction A plus reaction B will be the total load 2000 kg. So from here we are finding reaction at A, reaction at B. For that we are taking moment about A. Moment is nothing but the force into the perpendicular distance. Force into perpendicular distance is called moment. I am taking moment about A, so that there will be a upward force called reaction B, and there is an downward force 2000 kg is acting at the midpoint, which is 1.5 meters from support A. Now I am taking moment about A, so RB, moment is nothing but force into perpendicular distance. RB is a force and the perpendicular distance is 3 meters. Before that I am taking anti-clockwise moment as positive and clockwise moment as negative. That RB is a force which will cause a anti-clockwise moment about A. If I am taking moment about A, the RB will cause a anti-clockwise moment, and the 2000 kg load, point load, will cause clockwise moment. Before that I am converting the 2000 kg into Newton in terms of Newton, which is nothing but 20,000 Newton, because the gravity I am taking 10 meter per second square. So that RB will cause anti-clockwise moment about A. So RB into 3 meters, I mean force into perpendicular distance, which is positive because it causes anti-clockwise moment, and then 2000 kg point load will cause a clockwise moment, so it will be negative 20,000 Newton into 1.5 meters is a perpendicular distance equal to 0, because the for an equilibrium sum of moment also should be equal to 0. So sum of moment should be equal to 0. So 3 RB minus 20,000 into 1.5, so it must be 30,000 equal to 0. So 3 RB equal to 30,000, RB equal to 10,000 Newton. Actually that 1000 kg will be shared here. 1000 kg into 10 meter per second square is nothing but 10,000 Newton. So we are verifying here RB is nothing but 10,000 Newton. As we already seen, RA plus RB is equal to total load. Total load is nothing but 20,000 Newton. If RB is 10,000 Newton, RA must be 10,000 Newton. So 10,000 Newton, I mean reaction at A is equal to 10,000 Newton, reaction at B is also 10,000 Newton. Now we are going to calculate shear force and bending moment at every point. For calculating shear force, I am taking point C also, which is midpoint. So, there are 3 points A, B, C. I am calculating shear force at A, B and C. Shear force is nothing but summation of all the forces, summation of all vertical forces is called shear force at, I mean shear force at A, shear force at A. As we already know that reaction at A, reaction force at A is 10,000 Newton. So, the shear force is also 10,000 Newton. Before that, I am taking that upward force as positive, downward force as negative for calculation of shear force. At A, which is 10,000 Newton, at C, as we already know that shear force is nothing but summation of all vertical forces at a particular point. So, at C, if I am calculating from A, summation of all the forces. So, already 10,000 Newton is acting at point A, 10,000, and 20,000 is there downward force. So, I am taking downward force as negative. So, minus 20,000 Newton, summation of all the forces nothing but shear force. So, 10,000 Newton will be there in terms of negative at point C. At B, I am calculating, as I already told it, I am calculating shear force from A. So, summation should be from A. So, 10,000 at A minus 20,000 and plus 10,000. So, it will be 20,000 minus 20,000 equal to 0. So, shear force at A is 10,000 Newton positive, at C 10,000 Newton negative, at B which is 0. So, now we finished about shear force calculation. Now, we will do bending moment calculation. BM is nothing but bending moment. As I calculated shear force at every point, bending moment also will calculate at every point. At A, as I already told that moment is nothing but force into perpendicular distance. At A force is there, force is nothing but reaction at A, force is there, but there is no perpendicular distance. So, it must be 0 at A, 0 bending moment. I am repeating that at A the force is there 10,000 Newton, but the perpendicular distance is not there. So, it must be 0, perpendicular distance is 0, 10,000 into 0, it should be 0. At C, a 10,000 Newton force is there for the distance of 1.5 meters. So, 10,000 into 1.5, and again 20,000 Newton is there which is acting at point C, but there is no distance. So, the component 10,000 into at point C is 0, I mean perpendicular distance is 0. So, the second component will be 0, first component is 10,000 into 1.5. So, 1.5 into 10,000, 15,000 Newton meter for bending moment. At B, 10,000 Newton into 3 meters, 10,000 into 3 meters minus 20,000 into 1.5 meters. It must be 30,000 here, here also 30,000. So, it will be 0 Newton meter at B. as we already know that the end points which is supported in a simply supported beam, so that bending moment is also should be 0 at both the ends. Here it is verified. Now we are going to calculate, I mean we are going to draw shear force diagram and bending moment diagram for the particular problem, which is shear force, bending moment. Bending moment at A is 0, at B 15,000 Newton meter, at C 0 for the diagram purpose. First of all, draw a baseline for shear force diagram. Draw a baseline. Baseline will represent point A, point C, point B as shown in the figure. As we already calculated, shear force at point A is 10,000 Newton, which is positive. This is positive region, negative region. At A, which is 10,000 Newton positively, so which is 10,000 Newton, and at C, which is 10,000 Newton negative. I am drawing down, which it is because of the negative region is here. If it is a point load, if the simply supported beam is under a point load, it should be a rectangular one. So, rectangular box is showing that which is under a point load, and again the point, I mean shear force at point B is 0. So, it is going to 0, 0 is here, 10,000, 10,000, 10,000. Clear. Next, bending moment diagram. Similar to the shear force diagram, we are going to draw a baseline which represents A, C, B. At A, bending moment at A is 0. Similarly, at C also 0. At B also 0. At C, which is 15,000 Newton positive. This is positive region, negative region, which is showing that 15,000 Newton meter. The simply supported beam is under a point load, so it should be a linear one, linear line. So, which will be connected by a linear line. If the simply supported beam is under a UDL or UVL, it should be a curved one, parabolic curve one. If it is under a point load, it should be a linear line. With this, the problem on simply supported beam with a point load is over. Next, we will see about the problem with the simply supported beam under a UDL. Now, we are going to see a problem on simply supported beam with the UDL, and we are calculating shear force and bending moment, and we will draw shear force diagram and bending moment diagram. As we already seen, a simply supported beam, I mean beam is an horizontal member and which will take vertical loads. Simply supported beam is nothing but a beam which will be supported at both the ends. So, here we are having a pinned support and a roller support, and which is under an uniformly distributed load. It is about 20 Newton per meter, and which is 3 meters. Again, the length of the beam is 3 meter, and the uniformly distributed load is acting throughout the beam, which is 20 Newton per meter. Now, we are going to see about the calculation of total load. If it is a point load, we will consider point load, but if it is a UDL, uniformly distributed load, we have to take a calculation of total load. Now, which is 20 Newton per meter is acting throughout the beam. The beam length is 3 meters, which means 20 Newton is acting at every meter. There are 3 meters, the load is acting throughout the beam. So, 20 into 3, 60 Newton total load is acting on a beam, clear. That 60 Newton will be acting at the midpoint, 60 Newton. We have converted that UDL into a point load. That point load will be acting at a midpoint. Similar to the previous problem, which is 3 meters. Now, we are going to calculate about reactions. Reactions at the supports. I am naming that support as A and B, which is the load, total load is 60 Newton, is acting at the midpoint. It will be shared to the supports evenly. So, it must be reaction at A must be 30 Newton and reaction at B also must be 30 Newton if it is acting at a midpoint. So, now we are going to calculate about shear force and bending moment. Which is 30 Newton and which is also 30 Newton, A, B, and I am taking the midpoint as C. Shear force, as we already know that shear force is nothing but the summation of all vertical forces acting on a beam. There are 3 vertical forces, namely 30 Newton, 60 Newton is here and 30 Newton is here. Shear force at A, I am summing the forces, I am summing vertical forces from A. So, which is 30 Newton at A. At C, which is 30, I am taking upward forces as positive, downward forces as negative. So, the 60 is downward force. So, I am taking as negative 60. So, it will be minus 30 Newton. And at B 30 minus 60 minus 30 plus 30. So, it will be 0 Newton at B, shear force at B is 0. Then bending moment, I am calculating bending moment from A. At A, as we already seen that in previous problem, the force is there, 30 Newton is there, which is acting at point A, but there is no distance, there is no perpendicular distance. So, at A, bending moment at A is 30 into 0, moment is nothing but force into perpendicular distance. Force is 30 and the perpendicular distance is 0. So, it will be 0. At C, that 30 is there and the perpendicular distance is nothing but 1.5 meters, because the C point is located at the midpoint of the section, and minus 60 into 0, there is no perpendicular distance. So, 30 into 1.5 is nothing but 45 Newton meter, and at B 30 into 3 minus 60 into 1.5. So, 90 minus 90, which is 0. So, shear force at A is 30, at C minus 30, at B is 0. Bending moment at A 0, at B 45 Newton meter, at C 0. Now, we are going to draw shear force diagram and bending moment diagram for the particular problem. Shear force diagram, S of D. Extend the projection, draw a baseline which represents the points A, C and B. Shear force at A, which is 30 Newton, positive 30, at C minus 30, at B, which is 0. So, now we will draw shear force diagram and bending moment diagram. We will start with B 30, and here which should be a linear line. Next, bending moment, baseline, point A, C, B. At A, which is 0, at C, at C, at B. At B is also 0, at C, which is 45 Newton meter, which is under a UDL, uniformly distributed load. So, it should be a parabolic one. So, with these two problems, we will conclude on introduction on beams and shear force and bending moment calculation for the simply supported beam with point load and UDL. We will see with the next session. Thank you.